Alright, let's go. Number 10. The block universe and the illusion of now. In 1905, a 26-year-old patent clerk named Albert Einstein published a paper that would quietly dismantle our understanding of reality. His theory of special relativity demonstrated that time does not pass at the same rate for everyone. A clock on a moving train ticks slower than a clock on the platform. A clock at sea level ticks slower than one on a mountaintop. Time, Einstein proved, is not a universal river flowing forward at a constant rate. It is a dimension that bends and stretches depending on motion and gravity. By 1908, mathematician Hermann Minkowski extended this idea into something far more disturbing. If time is a dimension like the three dimensions of space, then the universe isn't a three-dimensional world moving through time. It is a four-dimensional structure where time is already laid out in its entirety. Past, present, and future exist simultaneously within this block. Every moment that has ever happened and every moment that will ever happen are equally real, equally present, equally fixed. This is called the block universe theory, and it is the dominant interpretation of time in modern physics. What makes this theory particularly unsettling is what it implies about your experience of the present moment. Your sense that now is special, that this instant is the only real one while the past has vanished and the future doesn't yet exist, is simply wrong. From the perspective of physics, every moment of your life is as real as this one. The day you were born is happening. The day you will die is happening. Your childhood exists somewhere in the block. Unchanged and eternal, alongside your last breath, consciousness creates the illusion of flow. We experience time as a sequence because our memories accumulate in one direction, but the moments themselves don't move. You move through them, or rather different versions of you exist at every point along your lifeline, each one convinced that their instant is the only real one. Your death has already happened. You simply haven't arrived at it yet. Number 9. Julian Barbour and the End of Time. In 1999, British physicist Julian Barbour published a book called The End of Time that proposed something even more radical than the block universe. Time, Barbour argued, does not exist at all. Not as a dimension, not as a flow, not as anything. What we call time is a statistical illusion produced by the relationships between unchanging configurations of matter. Barbour's theory is called timeless physics, and it begins with a simple observation. When physicists write the equations that govern the universe at the quantum level, time often disappears from the mathematics entirely. The Wheeler-DeWitt equation, one of the foundational attempts to unify quantum mechanics with gravity, contains no time variable at all. The universe it describes is static, frozen, a single mathematical object with no past and no future. Barbour took this seriously. He proposed that reality consists of an infinite collection of moments he called nows, each one a complete snapshot of the universe's configuration. These nows are not arranged in a line. They simply exist, like points scattered through a vast abstract space. Some of these configurations happen to contain records of other configurations. Your brain right now contains memories of a morning that appears to have preceded this moment. But that morning isn't behind you in time. It's a separate. Now that happens to share structural information with this one. The sensation of time passing is your consciousness correlating one static snapshot with another. You are not moving forward. You are simply present in one, and that now contains the imprint of others. The implications are annihilating. Nothing ever actually happens. The universe doesn't evolve. It doesn't change. Every moment you have ever lived is a separate, eternal configuration that will never cease to exist and never truly occurred. Death is not an ending, because there is no process of ending. You are a pattern embedded in a timeless structure along with every other version of you that ever seemed to exist. Number 8. The thermodynamic arrow and the illusion of direction. In the 1850s, physicists Rudolf Clausius and William Thomson formulated the second law of thermodynamics. Entropy, the measure of disorder in a closed system, always increases. A shattered glass does not reassemble itself. Heat flows from hot to cold, never the reverse. Eggs do not unbreak. This seems to prove that time has a direction. The past is the low entropy state, the future is the high entropy state, and the arrow of time points from one to the other. But physicists have discovered something deeply strange about this arrow. The fundamental laws of physics, the equations that govern particles, forces, and fields, are all time symmetric. Run them forward or backward, and they produce valid physics either way. A video of two billiard balls colliding looks physically correct whether you play it forward or in reverse. The laws themselves do not distinguish between past and future. So where does the arrow come from? The answer most physicists accept is that time's direction is not a feature of time. It is a feature of the initial conditions of the universe. The Big Bang happened to begin in an extraordinarily low entropy state, and everything since has been unwinding from that starting configuration. The arrow of time is not pointing forward because forward exists. It is pointing forward because we are sliding down a statistical gradient. What makes this particularly disturbing is what it suggests about direction itself. If the arrow of time is just thermodynamic drift, then forward is not a fundamental property of reality. It is an accident of how the universe started. In a different initial configuration, the arrow could point the other way. In some theoretical models, it already does. There are regions of reality, perhaps entire universes, where beings experience time flowing in what we would call reverse, remembering the future and being surprised by the past. Your memory of yesterday is not evidence that yesterday came first. It is evidence that you happen to be sliding in one particular direction down a slope that has no inherent orientation. Time is not passing. Entropy is simply increasing, and your consciousness is mistaking one for the other. Number 7. The Wheeler-DeWitt equation and the frozen universe. In 1967, physicists John Wheeler and Bryce DeWitt attempted to write down the equation that would describe the entire universe quantum mechanically. The result should have been the most important equation in physics. Instead, it produced a paradox that has haunted the field for over 50 years. The Wheeler-DeWitt equation describes the quantum state of the universe as a whole. When you solve it, you find something impossible. The equation has no time variable. According to its mathematics, the universe does not evolve. It does not change. It exists in a single, eternal quantum state with no past, present, or future. The wave function of the cosmos is frozen. This is called the problem of time in quantum gravity, and no one has solved it. Some physicists propose that time emerges from the relationships between subsystems within the universe. A clock and an observer, both contained within the frozen whole, can appear to experience change when measured against each other, even though the universe containing them is static. Time, in this view, is not a fundamental feature of reality. It is an emergent property that arises only when you divide the universe into parts and compare them. Outside of that internal comparison, nothing moves, nothing happens. The universe simply is. What makes this particularly unsettling is that the Wheeler-DeWitt equation is not a fringe idea. It is one of the most serious attempts to unify quantum mechanics with general relativity, and its conclusion is that time, the thing you feel passing right now, does not exist at the most fundamental level. Your sense of duration is a local illusion generated by the internal structure of a frozen universe comparing itself to itself. You are not living through time. You are a pattern inside a static mathematical object, and the motion you feel is the object examining its own structure. Number 6. Presentism, eternalism, and the war over what exists. In philosophy, the question of whether time is real splits into two opposed camps. Presentists argue that only the present moment exists. The past is gone, the future hasn't arrived, and reality consists solely of this instant. Eternalists argue that past, present, and future are all equally real. The block universe is their position. For most of human history, presentism was the obvious answer. Of course, only now exists. You can see it, touch it, feel it. The past is just memory. The future is just anticipation. Nothing could seem more certain. But modern physics has made presentism almost impossible to defend. Special relativity demonstrates that there is no universal present moment. Two observers moving relative to each other will disagree about which events are simultaneous. For one observer, an event on a distant planet is happening right now. For another observer moving past at high speed, that same event happened years ago. For a third observer moving in a different direction, it hasn't happened yet. If there is no universal now, then now cannot be what makes reality real. If two observers disagree about which moment exists, either one of them is wrong or both moments exist equally. The second option is what the mathematics strongly suggests. This means presentism requires the universe to have a privileged reference frame, a cosmic now that is truly real while all other nows are not. Einstein's physics forbids this. The laws of nature do not single out any frame as correct. Every observer's present is as valid as every other's. The conclusion is that either physics is wrong or every moment exists. Most philosophers who have followed the argument carefully have accepted eternalism. Your present feels real because you are in it, but the moment you are in is not metaphysically different from any other moment. It is simply the one your consciousness happens to be occupying, and your consciousness occupies every moment of your life with equal reality. Number 5. The Rietdijk-Putnam argument and the reality of the future. In 1966, philosopher C.W. Rietdijk published a short paper with a devastating conclusion. Using only the accepted principles of special relativity, Rietdijk argued that the future must already exist. Hilary Putnam published a similar argument the following year. Together, their work is known as the Rietdijk-Putnam argument, and it has never been successfully refuted. The argument proceeds in steps. Consider two observers, you and a distant being in the Andromeda galaxy. You are standing still. The Andromedan is walking. According to special relativity, the set of events that are simultaneous with right now for you and the set of events that are simultaneous with right now for the Andromedan are different. Because of the vast distance between you, even a small difference in motion produces a large difference in simultaneity planes. This means that if the Andromedan walks toward you, their now includes events on Earth that are in your future. If they walk away, their now includes events on Earth that are in your past. Here is where the argument turns. If only the present exists, then what exists changes depending on whether the Andromedan walks toward you or away from you. This is absurd. The Andromedan's walking pace cannot determine which Earth events are real. The only coherent resolution is that all of these events exist equally. Your future is not waiting to happen. It is already there, accessible to observers in different motion states, as real as your present. Somewhere in the universe, a being in a different reference frame is treating the day of your death as their present moment, right now. The mathematics are absolute. If special relativity is correct, and no experiment has ever contradicted it, then the future exists. You are walking toward events that have already occurred from the perspective of the cosmos. Number 4. Quantum gravity and the emergence of time from entanglement. In 2013, a team of physicists led by Ekaterina Moreva at the Istituto Nazionale di Ricerca Metrologica in Italy performed an experiment that offered a glimpse into one of the strangest ideas in modern physics. Time, their results suggested, might not be fundamental at all. It might emerge from quantum entanglement. The theoretical foundation was laid in 1983 by physicists Don Page and William Wooters. They proposed that an observer inside a quantum universe would perceive time passing, even if the universe as a whole is timeless, as long as the observer's quantum state is entangled with the rest of the universe. The entanglement creates a correlation between the observer and the system they are measuring, and this correlation produces the sensation of change. Moreva's experiment tested this idea using two entangled photons. One photon acted as the clock, the other as the observed system. When the two were entangled, an external observer saw the system as static, unchanging, frozen, but an observer who was part of the entangled system perceived change. Time appeared to flow for the internal observer and not for the external one. Time, in this experiment, was not a background parameter. It was a relational phenomenon that emerged from the quantum correlations between parts of the system. What makes this particularly disturbing is the implication for your own experience. If time emerges from entanglement, then your perception of time passing is not evidence that time is real. It is evidence that your brain is quantum correlated with the rest of the universe in a specific way. A different pattern of entanglement would produce a different temporal experience, or none at all. You are not observing time. You are entangled with reality, and the entanglement is what you mistake for duration. Break the correlation, and time does not slow down or speed up. It simply ceases to exist for you. Number 3. Loop quantum gravity and the discreteness of time. For most of human history, time was assumed to be continuous. Between any two moments, you could always find another moment. Time flowed smoothly, infinitely divisible, like a line on a mathematician's page. In the 1980s and 1990s, physicists working on loop quantum gravity, including Carlo Rovelli and Lee Smolin, proposed something that violated this ancient assumption. At the smallest scales, time is not continuous. It is granular, discrete, chopped into the tiniest possible units, approximately 10 to the negative 43 seconds long, a duration known as the Planck time. Below this scale, the concept of time breaks down entirely. You cannot ask what happened in between two adjacent Planck moments, because there is no in-between. Time is not a smooth flow. It is a sequence of distinct instants, like frames in a film, each one separated from the next by a gap that contains no time at all. This discovery leads Rovelli to an even more radical conclusion, which he laid out in his 2018 book, The Order of Time. At the fundamental level, Rovelli argues time does not exist. What exists are events, discrete quantum happenings, and the relationships between them. Duration, flow, the sense of time passing, all of these are statistical effects that emerge only at large scales. Zoom in far enough and time disappears, replaced by a foam of disconnected events with no intrinsic ordering. The implications reach into your own experience. The smooth flow of your consciousness, the seamless stream of thought and sensation is not what it appears to be. It is a sequence of discrete instants separated by gaps where nothing exists, including you. Between each Planck moment of your awareness, there is no awareness at all. You are flickering in and out of existence approximately 10 to the 43rd times per second, And the continuity you feel is a statistical average imposed by your brain's inability to perceive the gaps. You are not a continuous being. You are a series of disconnected stills, and the film is playing itself. Number 2. Retrocausality and the future affecting the past. In 1978, physicist John Wheeler proposed a thought experiment that should not be physically possible. He called it the delayed choice experiment. A photon is sent through an apparatus that can either measure it as a particle or as a wave. The choice of which measurement to perform is made after the photon has already passed the point where it would have had to decide which form to take. Wheeler's prediction, based on quantum mechanics, was that the photon's past behavior would depend on the future choice of measurement. In 1984, the experiment was performed. Wheeler was right. The photon's behavior in the past was determined by what happened later. The future reached back and rewrote the past. This is called retrocausality, and in quantum mechanics, it is not a fringe interpretation. It is an experimentally verified phenomenon. In 2007, physicist Vincent Jacques and his team at the Institut d'Optique in France performed a more refined version of the delayed choice experiment and confirmed the results with greater precision. The causal structure of reality at the quantum level does not run only forward. Information and influence flow in both directions through time. Several serious physicists, including Hugh Price at the University of Cambridge and Ken Wharton at San Jose State University, have argued that retrocausality is not just a quirk of quantum mechanics. It may be evidence that our basic picture of time is wrong. If the future can influence the past, then the past, present, and future are not arranged in a strict causal sequence. They are woven together into a structure where causation flows in both directions. What makes this particularly disturbing is what it implies about agency. Your decisions may not be free choices that produce future consequences. They may be partly determined by events that have not yet happened, events that are reaching back through the quantum substrate to shape the neural patterns in your brain right now. The thought you are having as you read this may have been caused by something in your future, and you would have no way to know. Time is not a one-way street. It is a medium through which influence flows in every direction, and you are floating in the current. Number 1. The holographic principle and the simulation of time. In 1993, physicist Gerard 't Hooft proposed an idea so strange that it took decades for the physics community to take it seriously. The holographic principle suggests that the entire three-dimensional universe, including its apparent flow of time, is a projection of information encoded on a two-dimensional surface. The idea emerged from the study of black holes. In the 1970s, Jacob Bekenstein and Stephen Hawking discovered that the information contained within a black hole is proportional not to its volume, but to its surface area. This was unexpected. Volume should hold more information than surface, but the mathematics were unambiguous. A black hole's informational content is stored on its boundary, not inside it. By the 1990s, and later, Leonard Susskind extended this principle to the universe as a whole. If the universe is informationally equivalent to a surface, then the three-dimensional reality we experience, including the passage of time, is a kind of projection. The fundamental level of reality is the two-dimensional information, and everything we perceive, including duration, is a reconstruction generated from that substrate. In 1997, physicist Juan Maldacena provided mathematical confirmation with the ADS/CFT correspondence, which demonstrated that a universe with gravity and time could be completely described by a lower dimensional theory without gravity and, crucially, with a different structure of time. The two descriptions are mathematically equivalent. Time in one is not time in the other. What makes this particularly unsettling is what it suggests about the nature of your experience. If time is a projection from a timeless substrate, then your sense of living through a continuous sequence of moments is a generated illusion. The information that constitutes you exists on a surface somewhere, outside of time, and the temporal flow you feel is a rendering, a playback, a reconstruction. You are not moving through time. Time is being assembled around you, moment by moment, from information that does not itself possess duration. Somewhere, on a boundary you cannot perceive, the entirety of your life is encoded as a static pattern. Your birth, your death, and every instant in between are written on a surface that does not change. The passage you feel is the surface being read. Your life has already been recorded. You are simply discovering it. If you want to see more videos like this, click the video on screen now and make sure to subscribe.